Hi everyone. My name is Anand Chaube. My research area is graph anomaly detection using deep learning techniques. Um, so let me start the screen share so that, okay. So as we know that anomalies are rare events that occur frequently in wide range of disciplines, for instance, uh, security, finance, medicine. For this reason, anomaly detection has been one of the vital tasks in the world and has shown its powers in avoiding detrimental events. Our work is based on presenting data as graph data and then using deep learning based methods to find either anomalous nodes in the graph or subgraphs or even anomalous graphs in graph database. We are also looking at developing methods that are computationally efficient. Some preliminary is about graph data. So this is the following taxonomy that we would follow in the research. Um, we have plain graphs, and they are static graphs, meaning as time passes, the number of nodes and edges are not changing, and they are represented by a set V where of n nodes and edges. And this can be represented by adjacency matrix, where n is the number. We also have attributed graphs. They are similar to plain graphs, but they also have information, attribute information about nodes, which will attribute is for each node is represented by a vector of size m. Then we have a third type of graph, which is dynamic graphs. Dynamic graphs have similar to attributed graphs, but they have nodes and edges changing over time. So just to provide some background into current existing research that have already been proposed and techniques that have already been implemented. Um, to summarize the background research, we can summarize it using this table in which across columns we have various representations like plain graphs, attributed and dynamic graphs, and also across rows we have different types of anomalies that are being detected. Like some research focuses on detecting anomalous nodes, some research focuses on detecting anomalous edges, and others focus on detecting anomalous subgraphs and even graphs. Um, I've tried to show here various types of techniques, representations and techniques that are being used. GCN, reinforcement learning, and other network-based representation, and even some non-deep learning techniques that have been used. So for example, if we take a node anomalous detection using plain graphs, we can categorize the research, the primary research into two main categories: traditional non-deep learning techniques, and then also network representation-based techniques. And using attributed graphs for node detection, we have deep neural network-based techniques. These techniques use autoencoders to encode and then come up with the reconstruction of the input. And the idea is that if the reconstruction, um, for benign, non-anomalous data points, the reconstruction error would be low if we have a good one. But for new um, and very odd, anomalous types of data points, the reconstruction error would be high because they occur rarely. And based on reconstruction error, we can come up with a scoring method to score the to score the nodes And then we can select top K nodes that would be my anomalous nodes. Similarly, other GCN-based and reinforcement learning, GAN, and other based approaches have been used that I have summarized it here. Um, so in terms of our research area, we are targeting to primarily focus on anomaly detection in large scale graphs. Um, as we know, most real world networks, such as online social networks like Facebook, Twitter, are large scale networks that contain billions of users and relationship links. Most existing works lack the ability to detect anomalies in such large scale data because they are transductive models, meaning the whole graph is used as input for analysis. Therefore, we see there is a need for a scalable graph anomaly detection techniques, and our research will investigate such techniques. We are just starting out with this research and have been exploring various techniques using graph-based approaches and deep learning-based techniques for anomaly detection. But seems like that focusing on larger scale graph definitely generate a lot of value, especially in practice. Thank you. That's all.